Okay, so this time, let's try solving another example wherein i-apply natin yung Newton's third law in solving problems. So say you have this person is riding an elevator, and this person has a mass of 50 kilograms. Now, he is riding on an elevator, pero he is on top of a weighing scale, no? So he is trying to measure gaano siya kabigat. However, as he is trying to measure, nagsuslow down na pala yung pagbaba ng elevator, and it is experiencing an acceleration that is equal to 0.200 meters per second squared. So, ang question nito is, what is the reading on the scale? So, normally, dapat 50 kilograms yung mabasa natin sa weighing scale. But since there is an added factor here that the elevator is decelerating, so nagsuslow down siya to a stop as it goes down. So, what is the effect of that slowing down doon sa reading nung weighing scale? So, like any other problem, let us begin solving itong problem na ito by drawing yung free body diagram. So, we'll start with the free body diagram nung person. So, for the person, simple lang yung free body diagram niya. Meron siyang weight, and that weight is directed downward. Let's label that weight of P. And then, meron siya na-experience na normal force due to the surface kung saan siya nakapatong. That is normal force on P. Now again, since our system is accelerating, so kasali doon yung person, the person is also accelerating, it is useful to draw yung direction ng ating acceleration. So acceleration niya is upward, and it has a magnitude of A which is equal to 0.2 meters per second squared. Okay, so from Newton's second law, hindi na natin titingnan yung sum of forces along the x. We will jump ahead sa sum of forces along the y-axis. And this should be equal to the mass of the person times the acceleration along the y-axis. So looking at our free body diagram, we have sum of forces along the y-axis. We have the normal force that is upward, so positive yung value niya. And then we have the weight of the person, which is downward, so negative yung value niya. And this should be equal to the mass of the person times the acceleration due to gravity. Na yung acceleration niya along the y, no, yung y component na acceleration is upward siya. Upward yung acceleration natin. So that should get a value of positive a. So yan dapat yung y component ng acceleration. So to make this simpler, ilipat natin itong weight ng p to the other side. So normal force, weight p, naging positive na siya kasi lumipat siya sa other side ng equation. And then we have the rest of the equation here. Now remember, the weight of an object is equal to its mass times the acceleration due to gravity. So we can rewrite this as mp times g, no? So yan yung weight niya, plus the rest of the equation here. Now since meron tayong mass of the person for both terms, we can factor that out. So we have the normal force, mp times g plus a. Okay? So this will be useful later, so we'll call this equation number 1. This time, we will look at the weighing scale. Ano yung forces acting on our weighing scale? So let's begin with the free body diagram ng ating weighing scale. So the forces acting on our weighing scale is the weight of the weighing scale. Tapos we have the normal force. This is from the surface, which is yung floor ng ating elevator. Tapos, in addition to that, since merong normal force na na-experience yung person, this normal force is actually coming from the weighing scale. Yun yung surface na nag-e-exert ng force sa ating person. So, galing ito actually kay weighing scale. So, in return, no, as a reaction to this force exerted by the weighing scale, merong may experience ngayon yung weighing scale na equal in magnitude but opposite in direction of force. So this is the reaction force experienced by the weighing scale galing sa person. So this force here, itong FSP, this is what the weighing scale reads. Kung anong value nung force na ito, just convert it to kilograms, and yun yung babasahin ng weighing scale. So another detail that we need is to just draw yung direction ng acceleration ng weighing scale. That direction is also upwards. Okay, so that's it. Gusto natin malaman ano ang value nitong FSP, and yan yung babasahin ng ating weighing scale. Now, we've seen kanina that the force exerted by the weighing scale dito sa free body diagram ng person, ang inexert ng weighing scale sa person is this force here, the normal force. So, ibig sabihin, itong reaction force that we have here is equal doon sa normal force exerted on the person. So, FSP is actually equal doon sa eta P. Okay? Therefore, in order to find the reading sa weighing scale, we just need to solve for FSP. Okay? So, from equation 1, we have FSP. Our normal force is actually equal to MP G plus A. Yan yung value nung force that we are trying to read, that the weighing scale is trying to read. So we'll simply substitute yung values natin to solve for FSP. So the mass of the person is 50 kilograms. Tapos acceleration due to gravity is 9.81 meter per second squared. Plus yung acceleration ng elevator and yung person, that is 0.200 meter per second squared. So, yan yung value niya. Now, we will plug this into our calculator and you should get a value of 501 newtons. So, ito yung gustong i-measure nung ating weighing scale. Now, to read this in kilograms, i-convert lang ito nung ating weighing scale. So, in order to do this, it will divide yung value ng force na ito by G. So, we have the force, 501 newtons. Then, divide lang natin acceleration due to gravity. So, ito yung ipapakita nung weighing scale. Plugging that in to our calculator, you should get 51.1 kilograms, which is actually heavier than the actual mass of the person, which is 50 kilograms. Okay, so ito yung effect nung pag-accelerate o pag-slow down nung elevator, no, as it is going down. Tapos, yun yung effect niya sa reading sa weighing scale. Now, if the acceleration is downward, you'll see the opposite effect. It will measure a lighter, no? Mas magaan yung mame-measure niya na mass kung pababa naman yung acceleration natin. Okay? So, this acceleration ng elevator has an effect doon sa reading ng weighing scale. Okay? So we see here yung principle ng Newton's third law. We are able to identify ano yung force na babasahin ng weighing scale by using Newton's third law, no? The force exerted by the scale doon sa ating person is this one here, the normal force. So ito yung force galing sa person to the weighing scale. Ito din yung i-exert nung person sa ating weighing scale. And that will be the source nung reading nung mass. Okay, so this is interesting, no? Iba pala yung reading kapag accelerated yung frame of reference natin.